This is covering or collecting evidence for Unit 308, Software Installation Learning Outcome 2. Okay, Arron, would you like to take me through the presentation and talk to me as if you're installing your operating system?
Okay. As you can see, the operating system I chose was Windows Vista. It was relatively easy to get a license for. So to install Vista on a virtual machine, you need to create a new virtual machine and choose the version as Windows Vista, because that's the operating system that's being run, and you need to name it relevantly. The next screen will ask you about allocating memory to your operating system. So what I done was I went with the recommended memory size, which was 512 megabytes.
So this is actually allocating it on the virtual machine, isn't it?
Yes.
Yes, okay, good.
Okay, and to select Vista, so to point the virtual machine to Vista, need to create a virtual hard drive. And again, you need to allocate a size limit for the hard drive.
How did you know how much space to allocate? Did you?
It does the recommended
Right.
for Vista itself, so they differ.
Okay, so it's clever enough to work out, right, the size bending on the operating system. Is that what you're saying? Okay, fine, clever.
And to point the virtual machine to the ISO, you need to create a controller, and your ISO would be in your document, so you literally just select it and...
Go on, sorry.
Yeah, so you select the ISO, and that way it points the virtual machine to it.
What's the ISO?
The ISO is it's basically the operating system before it's been on a disk.
Oh, okay. Okay, so it's what gets created before it gets burnt onto the CD. Is that what you mean? Okay, so why use an ISO then rather than a DVD or CD?
Well, you couldn't actually use a DVD on a VM box.
Okay, so just tell me again, where is this ISO coming from?
It was from Microsoft itself.
Oh, yes, but where was it stored?
In my downloads.
Okay, so you just so you downloaded it from Microsoft.
Yeah.
Got you, and you put it onto your downloads. Okay, that's fine. Fine, just checking.
Fine. And okay, so once you've pointed the VM to the ISO, you're then ready to install. So just by powering on the machine, the first screen that comes up is asking you about your keyboard settings. So initially it started off with English, United States, but to avoid difficulties, I've changed it to the UK.
Okay, so when you say difficulties, what are you actually setting here?
Just like language and time.
Okay.
So, for instance, if it was on the US, like you might have type errors where the machine will be telling you that you're spelling something incorrectly, but will be using a different dictionary. Effectively.
Okay, and what about keyboard settings? Does it alter the keyboard settings?
It does, yeah.
Can you give me an example? If you left it on US, what would we get that would be a bit confusing?
Such as, I would say, the pound and the dollar.
Yeah, it's important, isn't it?
Yeah.
And are you aware that the 2 and the @ sign swap around as well on a US keyboard?
I did notice that.
Yeah.
To be honest, I wasn't sure why I'd done that.
Oh, that's what it is. Yeah, it's the keyboard setting. So the 2, what's above the 2 and the @ sign, they reverse. And I think, if I'm not mistaken, Europe, so in Portugal, when we go into the internet cafe, we have to do, I think it's Control Alt and 2, or Control, to find the @ sign. So it's all different. Yeah, there you go. Good. Okay.
And once you've done that, comes onto the terms and conditions for the licensing terms, but to install the operating system, you need to accept the licensing.
Yeah, you can't go forward, can you,
No.
without ticking that box. So what are Microsoft forcing your hand at then? Because you're right, it says it's very clearly Microsoft software licensing terms.
Yeah.
So what are they forcing you to do?
To agree with what they're saying and their terms and conditions.
And therefore, if you tick the box and then you broke those rules, what could Microsoft do?
Well, you'd be breaching the contract that you're effectively signing with them,
Yeah.
meaning that they could fine you.
Exactly. So do you remember yesterday we talked about copyright?
Yeah.
Yeah, and you mentioned it, I think. That's what we're looking at here, isn't it?
Okay.
Okay, good.
Okay, so once you've accepted the licensing terms, you can then continue with the install.
Good.
The next screen is installing on a partition.
Mm-hmm.
So initially it come up with three partitions, but I needed to format each drive to choose where I'd install Windows.
Okay. And where do we normally install an operating system? What drive letter?
Usually on the C drive.
Okay. So you've got one partition here. Why on a Vista box? Probably more at home than in work, to be fair. Why might you split that in half and put the operating system on one half and the data on the other half, for example?
Just for, well, you could say for security reasons, and safety. So that way you know that what you're saving isn't going to overwrite Windows files.
Yes. And think about this. What if the operating system got corrupted? What would you have to do?
Well, if your data's on there, then on the same drive, then that would get corrupt, meaning that you would need to either revert back to last best known configuration, or even do a clean install.
Okay, but if your data was on a separate partition,
Then
would your data be affected?
No.
No.
You could back it up, and then once you've reinstalled Windows, you can put it back on that drive.
If you needed to, yeah? Okay, yeah, good. All right.
Okay, and then the next one asked if you wanted to do a custom or a upgrade.
Mm-hmm.
So an upgrade keeps existing Windows files, and it's literally just going from the operating system that you're on and dragging the files onto the newer one.
Right, yeah, I like the way you say dragging. Okay, do you think it takes longer or a shorter time to do an upgrade? Do you know?
I would say it would take longer,
Yeah, it does.
because it's got to transfer what you've already got saved on.
Yeah, it has to do a comparison as well, doesn't it? Yeah, because if you were upgrading, let's say, from XP to Vista, they're quite different, aren't they?
They are.
Okay. As well as upgrading the operating system and any of the program files, what else does it actually take across that you might not want? Think about what your machine kind of collects as it progresses through its life.
Yeah, it just collects unneeded files.
Yeah.
Effectively, it just builds up.
Yeah.
And clogs up space.
Yeah, exactly. So you're upgrading that as well.
Yeah.
We call it rubbish. Does that make sense?
Yeah.
So you're upgrading your rubbish as well. Okay, so which is why we actually always recommend what you're about to tell me about. So tell me about the other option you have there.
And the custom install is where it's a brand new copy of Windows. So it's basically starting from scratch once the operating system's installed.
And again, if you've got data in either of those situations, what should you do with your data before you do anything?
Back up, and then if you do need to put it on your new operating system, then you can just copy it over.
Good, yeah. Excellent. So you went for a custom install, yes?
Yeah.
Excellent, good.
Okay.
Don't worry, you've told me about that. Although I can just go back again. You've got a computer to be set up here. Okay. Just tell me about what this says here.
Okay. Well, we do custom install here at WorkNet, and for a computer to be set up here, our build consists of installing certain softwares on the machines for the clients, making it more convenient for the end user. The computer will have certain compatibilities with the software, depending on whether or not it's the correct version which is being installed. We recommend that it's checked whether the computer is 32-bit or 64-bit before proceeding with installing a package.
Why is that so important? Because you're right, you do need to check it these days. Because in the old days it was just 32-bit, wasn't it? But now they generally release 32-bit and 64-bit. So why do you need to check that?
Well, if you're on a 64-bit machine and you've installed a 32-bit software, I'm not saying it's not going to work, but there may be problems.
Can you put a 64-bit on a 32-bit?
It won't work, no.
No, good. No, you're absolutely right. So you can put 32-bit on 64-bit, but generally we don't recommend it because it's not going to achieve anything, is it? Because 64-bit's meant to be faster.
Yeah.
But if you put old on new, we always know it runs at old. Yeah? Good. Okay,
Yeah.
fair enough. Move on.
Okay, and then, so next screen is installing Windows. So as you can see here, it's expanding the files, which is, within the ISO, it's got compressed, well,
Yes.
not just the ISO in general. So
Yeah.
if you was to do it from a disk, it's got compressed files, which once you install Windows, it just expands them onto the hard drive. So it does take a while to do this, but it's the base of the operating system.
Good.
And then once that's done, it's booting into your operating system. And once you've booted in, it gives you the option to set up your account. So as you can see here, it says, well, it asks for a username and a password.
Okay.
And then before actually going onto Windows, it gives you a chance to review your time and date settings. And once you're in, once you've done that, the operating system's successfully installed, so you can then carry out what you need to do. So for instance, if there is any data that needs copying over, then you can do that.
Just before you go any further, I notice it says computer name user PC. I didn't see a screen. Did we miss that, or? It's got the user account there. Okay, don't worry. It must have picked it up somewhere. Tell me a little bit about computer names. Let's assume this box is going on to a network. So, what must the computer name be and why?
Well, the computer name, also known as the host name, is well. If it's going on a network, it needs to be. I'd say unique.
It is.
So if it's on a network, it could potentially, we could push out updates to this machine. It just basically helps us pick up on the computer.
Yeah, it's a way of you guys identifying a computer. But as it happens, there's more to it than that. Your network uses the computer names as well to communicate. So when you log on, your computer is recognised by its name, nothing else, initially. And then it looks at IP address and so on and so forth. So you're right. And just think, when you map a drive, do you usually map to an IP address or a name?
We usually do it to the name itself.
So why do we choose names rather than having to remember IP addresses?
Well, names they're static, so it's secure. I mean, it takes a lot of difficulty to change a host name.
Yeah, there is that. But what about ease of remembering?
Well, yeah, the computer names are often short. So I mean, in this case, it's user-PC.
Yeah.
Whereas,
Do you know its IP address off the top of your head?
no.
Exactly. Yeah? So it's a lot to do with ease. Yes? Because we need to use it in different circumstances rather than having to remember the IP address the whole time. We go, no. Okay? Good.
Okay.
Right. That's fine. Move me on to the next screen that we just seen. Okay, so here you've got, tell me, what are we looking at?
This is on command prompt, where I've just got the Windows IP configuration up by typing in IP config.
Right.
So it's, as you can see, on this OS, it's got an IPv6 address as well as an IPv4.
Good.
It's got the subnet mask in the default gateway, so it shows it's connected to a network.
Okay. Can you tell me what the IP address actually represents?
It's basically a unique string of numbers, which is often, well, it's allocated by the DHCP. That helps the machine connect to the internet.
A bit more than that. Let's say we haven't got internet access. Do we still need IP addresses?
We will, just so machines can communicate with each other.
Do you know what it actually represents?
No.
Okay, so an IP address, it's a way, as you quite rightly say, it's a way of identifying the machine on the network. Okay, so we say it identifies the where and the what. So when we talk about the where, what we're talking about is which network is it on. And then when we're talking about the what, we're saying, okay, what is it? Because we can give an IP address to anything, can't we?
We can.
It could be a fridge on the network, couldn't it? And as long as it's got an IP address, we can identify it using that address.
Yeah.
Okay, so it's the where is it? And it's the what. So it's a bit like, I usually, when I'm teaching this, I refer to streets and houses. So the network portions are the street name, yes?
Yeah.
Okay, and the host portion is what we refer to the house as the house number.
Okay.
Okay, so the numbers that you're seeing there, if we didn't have the mask in place, it's what we call a Class A address, and normally the 10 would be the where, and the rest of it would be the what. Okay, the 0.2.15. Okay, but because the mask is 255.255.255.0, somebody's played around with it, that now tells me that the where, the network ID, is 10.0.2 and the host ID is 0.15.
Okay.
Okay, now that's something that I will test you on again later, okay, because it's really important you know that.
Okay.
Yeah? Okay, so do you know what the mask is meant to do, generally? Based on what I've just said, if I said to you, I can look at that mask and tell you that the network portion of the IP address is 10.0.2 and the host portion is the .15, what's the mask doing for me? How can I know that?
Well, because there's zero on the end, doesn't it? So on the subnet mask, it only goes up to 255 on each.
Yeah, there are certain numbers you can have. 255 is the default number that you can have in there.
Okay.
All right, go back to my streets and houses. If I said to you 10.0.2 was known as South Road, look at the mask. Do the 255s not correspond to the network portions?
They do.
Okay, so what does it do then? The mask does what for the address?
Provides, so where there's 255.255.255,
Yep.
it links in with the first three
Octets.
octets of the IP address.
It does. But what's it doing for the IP address? It's kind of splitting it, isn't it?
Yes, and by there being 0 at the end, that links in with the 0.15.
Yes, it is. Which is what? Network or host?
That would be the host.
Yes. Yes. So the mask simply does the split for us, yes? If you get to know your masks, which you need to do, then you'd be able to identify very quickly which portion is network and which portion is host. So what the system does is says if there is a number greater than 0 in the subnet mask, then the corresponding octet in the IP address is part of the network ID. So in other words, if the number is 0 in the mask, that's host ID.
Okay, so if it's 255.255.255.255.
Can't have that.
You can't.
No. You can only have up to 3 portions, really. It's 255. That's not strictly true, actually, but for today's session it is. Okay. So if we had, let's do it this way. If it was 255.255.0.0, tell me what the network portions are of the IP address.
10.0.
Yeah. Simple, isn't it? And if it was just 255.0.0.0,
it would be 10.
Yeah.
Yeah.
Yeah. And therefore the others. So we say it masks the host ID to leave us with the network ID.
Okay.
Does that make sense?
Yeah.
Okay, good. Right, what about the default gateway? What is that? What's that pointing to?
That's pointing to the IP address. By the IPv4 address.
Okay, but what's it representing? The IPv4 address of what?
The network.
Not exactly. How do you get out onto the internet? What do you have to go through to get out onto the internet?
So.
Forget that wording for a moment. Just forget that. Forget default gateway for a second. But if you want to go out onto the internet, be it at work or at home, what do you have to physically go through? What have you got at home? Go on.
Just to browse to the internet.
Yes, but what have you got? You must have something physical to take you there.
A router.
That'll be the one. That's what a default gateway is. Microsoft just confuse us all.
Oh.
Exactly. So the default gateway is Microsoft's term for a router.
Okay, so that's the router's IP address.
Correct. Okay, so here you'll have a router to take you out to the internet.
Yeah.
Yeah? Okay, that's your default gateway. Okay, so Microsoft like confusing us, as we know. All right, now there's one that's missing there because you've done an IP config without the /all switch, but it's DNS. Just tell me what you know about DNS. What's DNS do? And again, think about what you do on the internet when you want to go to a website.
Okay, so DNS, it's the domain name server, so it helps the machine point to certain websites.
It does, okay, but when we talk about a website, where is the website sat? What's it sat on? It's got to be sat on something physical, hasn't it? What's it sat on?
The web.
Yes, but the website is on a physical box. What do we call them?
On a router.
No, it's the server.
Server.
Okay, so you've got hundreds and thousands of servers out there, yes?
Yeah.
Okay, do you know the IP address of Microsoft server, for example?
No.
Do you want to? So how do you get to that server? What do you type in when you go to the internet, to the web browser?
You would just, if I wanted to go to Microsoft server, you just type that in, for instance.
What? Type what in?
Microsoft server.
What's a website address?
Well, you wouldn't know what the website address would be.
Okay, what if you wanted to go to Google?
Then you would type in Google's domain URL.
Which is?
www.google.co.uk.
Right. and you're going to a server.
Yeah.
Because it doesn't sit in the ether, it sits on a box.
Yeah.
And you're actually trying to get an IP address. But you don't need to know the IP address.
Okay.
Why not?
The DNS would pick it up.
That's it.
And then
Take what you've typed in, which is what? Name or number?
that would be the name. And
Perfect.
it converts it to the number
Yes.
for the computer.
Yes. Can you imagine, in the big wide world, if everybody had to go, what's the IP address of Microsoft.com?
It would just be difficult.
It would never happen, would
No.
it? It would never work. So we don't have to do that. We know that we can go www.microsoft.com, bang, DNS does it for us. We have internal DNS servers, so on your network you'll have a DNS server to do exactly the same thing. I asked you earlier, how do you map to a drive, or when you map a drive, do you use name or number?
Use name.
And what are you trying to get to?
A server.
Correct. And how's the server actually identified?
Through DNS.
Yes, but what are we trying to get to? It's on your screen there. What are we trying to get to?
The IP address.
Yeah. But again, do you know the IP address of all your servers on your network?
No.
Do you need to?
No.
Why not?
Because DNS does it for us.
Good. Does that make sense?
It does.
Well done. Yeah, absolutely right. And thankfully, that it's there because, as I said, it would never work, would it? I mean, on a small network internally, yes, of course, you might get to know your IP addresses, and lots of people do. But hey, it's a lot easier to go server 1, server 2, yeah? Or exchange server. DNS does it for us. Good, okay. Brilliant. Okay, so you've popped all this up, but it's nice to be able to go through it without you reading off your screen because you need to understand it. Okay, so, what's the next screen? Okay, yes, we've done that, computer name and keyboard settings. Yes? Brilliant. Okay, I think that concludes the evidence then for Unit 308, Learning Outcome. I'm going to say 1 and 2, and I want you to upload it to both. Okay? Brilliant.